Acoustic emission is a simple method of determining the health of rotating elements. The instrument listens for frictions and impacts caused by poor lubrication or bearing damage. Sound is generated by bearings, and this propagates through the structure of the machine. Using a sensor to pick up the signal, you can detect this noise, and using signal processing, determine the condition of the bearing. Kittiwake Holroyd's acoustic emission technology has been used on all types of rotating equipment for over 20 years. Using the MHC bearing checker is simple. With just 2 buttons on the unit and an easy-to-interpret display, measuring the condition of your critical assets bearings couldn't be simpler. To turn on the MHC bearing checker, push and hold down the power button. To take a reading using the MHC bearing checker, press and hold the measurement button. This starts a 10-second countdown to attach the unit to the machine using the magnetic sensor head. Orientation of the unit is not critical, as sound waves travel in all planes. However, joints reduce the amount of sound transmitted through a structure. Ideally, select a point on the machine that is as close to the bearing as possible, but with the fewest joints within the sound path. The sensor should not be placed on loose covers or guards that are not directly connected to the source of the sound. To take a measurement, apply a small amount of grease to the measurement point to ensure a good audio coupling. Carefully place the sensor on the measurement point at 45 degrees and, using a rolling action, flatten the sensor onto the test pad or location. Twist the sensor slightly to make sure that good coupling is achieved. Allow the readings on the display to stabilize and then take measurements of distress and decibels. Interpretation of data. The MHC bearing checker provides 2 easy-to-interpret parameters, distress and dB level. Distress is a measurement that quantifies the impacts occurring within the rotating element being measured. Even in brand new bearings, impacts will occur. The base level for distress would be the perfect bearing, which would theoretically have a distress figure of 0. In real life, bearings usually start their lives with a distress value of 2 or 3. During the life of the bearing, this value trends upwards. Experience over many years has shown that if a bearing shows a distress value in excess of 10, the bearing should be lubricated and the distress value rechecked. If the value of distress remains above 10, then further investigation and possible replacement of the bearing should be considered. dB level quantifies the frictional activity taking place and cannot be easily estimated. The level of decibels is dependent on the speed of the bearing, but only increases as wear increases for the same rotational speed. Usually, the user would take a first reading and trend from that value or compared to a similar machine of similar age doing the same job. By trending this, the user can monitor the speed of degradation. A rapid increase in dB level is normally the final warning prior to bearing failure. As has been shown, using and interpreting the results from the MHC bearing checker is simple. As a low-cost introduction to monitoring your critical assets using acoustic emissions technology, can you afford not to equip all of your maintenance professionals with a unit?